Hey, in this video we will be making a vector class out of our string bag class. If you remember, string bag had a couple of issues as a container. It couldn't grow, it couldn't expand to fit more elements once it was full, and it couldn't contain anything other than strings. So we'd like to fix that by creating a vector class. So I'm in Visual Studio and I'm going to be making a new project, and I'm going to copy over my string bag code so that I can have something to start from. Alright, let's make a new project. I'm going to call it custom vector. Okay, I also want to go find my string bag project and right click on it, open folder in File Explorer so that I can grab the string bag code. You may have split this up into multiple files, but I only did the very beginning of this class, so I just have one file. I'll be bringing that, but you should bring your CPP implementation file as well. I'm going to copy it and take it to my custom vector directory that's been created from that project and paste it in there. I'm going to rename it vector.h. Okay, and then in my custom vector project, I can right click on it and add existing item, choose my vector header file. Okay, so first thing is to go through and I'm going to rename this stuff. It's not a string bag in this project, it's a vector. And so every place that it refers to string bag, I can replace that with vector. Okay. And then the second thing is that it shouldn't store strings anymore, it should store integers. Alright, every place where it refers to string can be replaced by int. I'm going to use this just as a placeholder. We're going to be talking about templates next, and we'll be able to replace this with a generic type that can then represent anything, not just integers. Okay, integers, int adds an integer. Okay. Int, and then let's name this something a little more meaningful. Value. Great. And our internal array now will store integers instead of strings. Okay, so the important part to add here is an ability for this vector to change its size. When I add a new integer into this vector, let's call this push back, I guess. When I push back a new element into this vector, I want it to be added on no matter what. I want, if there's no more room in the vector, I want to make the vector bigger, change my internal array so that it points to something bigger. So if you remember, we cannot change the size of an array, so we're going to have to fake it. We're going to have to swap it out for a larger array. We'll make a temporary array, or at least a temporary pointer to a new array of the right size, copy over our values, and then swap the pointers so that we're referring to this one. The user won't know anything different because they are just using our vector through the functions that we provide. We provide the interface and hide all of these details. Alright, so in pushback, if I had my resizing functionality in here, what I'd like to happen is that no matter what, I'm going to be adding this value into my array and increasing the size of my vector. So I don't really need this stuff here anymore. If size is less than capacity, okay. Well, I do want a special case if the size is going to exceed the capacity. So if size is equal to the capacity, so we've already gotten there, then I would like to reserve more space. So let's pretend we have this function. I'd like to maybe have a little extra space so that I can guarantee that I can then have the space to store one more value. Alright, so that's the way I want it. Now I can write this function, reserve. Reserve is going to take a new capacity, and it's just going to make sure that we have enough space. So if the current capacity is less than the new capacity, this is when we need to grow the array, grow in quotation marks. Otherwise, we already have enough space. We don't need to grow it. So if we need to make the array bigger, what we need to do is make a new array that is the right size. So new capacity, number of integers. Then we're going to copy over all of the contents into this new array. So I'll do a loop for that. Alright. Each element of new array gets its value from the corresponding element of the contents array. And then once we've copied over all of the old values, we can delete the old array and replace it with the new array. So change the pointer contents to point to the new array that we just allocated. Alright? And then our capacity can be set to the new capacity. Great. Right, so next we need a resize function. We're going to have to decide with resize what exactly that means for our program. The resize function should take in a new size, but we have to choose what exactly that's going to do. You could make it so that no matter what size is chosen, it creates a whole new array of exactly that size and copies everything over. That means that when you resize to a smaller size, it's going to free up memory. When you resize to a larger size, it's going to allocate more memory, and it's going to allocate exactly how much memory you need. Or you can do something that's a little bit less allocations, fewer allocations, but maybe a little bit, you might say wasteful of memory, but memory is cheap nowadays. Computation is more important, computation time. So I'm going to go with that approach where if the new size is smaller than the current size, I'm not going to change anything. I'm just going to set the size to the new size and pretend like we had removed elements. So we can just say if new size is less than size, then size equals new size. All right, and then if you were looping over this array, you would just loop over fewer elements, and it would be as if ones were removed. The capacity hasn't changed though, so we haven't actually deallocated anything. Very simple operation there. Otherwise, else if new size is greater than size, then we're going to need to perhaps grow things. So we actually only need to grow when our new size is greater than the capacity, if there's not enough space to hold all of these new elements. Because eventually we're going to end up doing the same thing where we change what our size says it is, but we're going to have to just make sure we have enough space. And that sounds like something that we just did with reserve. So let's make sure that we have new size number of elements, and then change our size there. So if you were actually going through this this container and checking these elements after you made it bigger, there might be garbage values in there, uninitialized values. So just be aware of that. There are ways around that, but we're just going to leave it as it is. All right, looks okay for me for now, and I will see you in the next video.